My name is Samantha Cope, and I'm going to speak today about using image processing techniques to maximize MPA monitoring for managers. I'd like to acknowledge my colleagues in this work at Protected Seas, Virgil Zetterland, and Brendan Tugger. Marine protected areas can be great tools for conserving marine spaces, but effective management requires monitoring vessel activity and human use to be sure regulations are followed. But continuous monitoring requires human and physical resources, like boat use and fuel, and this is even more challenging in remote locations. There has been significant development in technologies that provide continuous monitoring, but now we're presented with a new challenge: the time and effort required to review all the data and how to do this efficiently. The Marine Monitor, or M2, is one of these technologies. M2 is a vessel monitoring platform that uses familiar tools to document activity of all kinds, from commercial shipping all the way down to kayaks. M2 uses a marine radar system to identify and track boats on the water, just like what you would use on a smaller boat for navigational safety. And a camera captures photos, so boat types can be classified. It provides data collection 24/7, done 100% autonomously, and can be deployed to remote or rugged areas, like the one shown here. M2 software uses the vessel positions from the radar to construct vessel tracks, showing activity over time. So here you can see the vessel position in the radar imagery and that it was lingering within the area. M2 data are sent to the cloud and available for users in an online platform called the M2 Viewer. In the map on the right, you see the path of this vessel as it traveled through an MPA, shown in the red outline. The icons along the track line show all the locations of the vessel when it was photographed. M2 typically captures an image of a vessel roughly every 2 minutes. Depending on how long the vessel was in the area, this can lead to a lot of images. And sometimes these images don't actually capture the vessel. In this instance, the vessel was traveling fast, around 17 knots, so it was out of the frame just before M2 captured the image. Position and tracking errors, like this example, and some weather conditions like fog, can result in unusable images. For MPA managers tasked with monitoring activity, these images can waste time and storage space on local computers and take up bandwidth when data are transferred to the cloud. This is especially relevant when managers have limited access to resources in the field. Because of this, we developed a simple model to classify images as either vessel presence or absence, without having to use a complex model that could require much more computing power. We created a heuristic model and looked at the reduction in images if absence images were ignored or removed. And finally, we evaluated the model's accuracy and how it might best be used. M2 software takes the vessel positions provided by radar and pans and zooms the camera to ideally capture images with the vessel near the photo's center, like the one shown here. Using Python for the process, we first removed the edges of an image that can have camera manufacture watermarks or distortion. Next, the clipped image was converted to grayscale to simplify image processing. Vessels typically appear darker or lighter than the sea, sky, or land around them. This histogram shows the distribution of darker and lighter pixels in the image. We use traditional thresholding to identify the very darkest and brightest areas of the image. Dynamic thresholding adapted thresholds per image based on the shape of the pixel histogram. Then, unique objects were identified that could potentially be a vessel. And finally, rules were applied to select the object that was largest and closest to the center of the image, to ultimately select the target vessel. Then, the image was classified as vessel presence. If there were no objects that met the criteria, the image was classified as vessel absence. There are 19 active M2 sites around the world today. We selected 6 sites to test the model on a month of data. The total number of images at each site in July 2022 are shown here, with all sites capturing more than 10,000 images each. At most sites, around half of all the images were classified as absence and presence. We reviewed just over 1,000 images across sites to assess model accuracy and found that around 73% of images were classified correctly. We also randomly selected unique vessel records from each site and looked at presence accuracy for each record. We found that vessel records had between 60 to 80% of presence images classified correctly, meaning that if images classified as absence were ignored, most images of the vessel would remain. The most common false classification of absence was due to vessels very far from the camera or very small in size. These can be helpful for confirming the vessel was there, but don't provide much information on what type of vessel it is or what it was doing. Images with obstructions in the foreground were often falsely classified as presence. Sometimes the vessel was still visible through the obstruction, so these could still be useful. We could likely improve model accuracy by including track attributes like distance and speed and ignoring areas that are consistently obstructed. The simple model is an effective way to reduce the number of images to review, store, and transmit to the cloud. But the accuracy of the model, which was around 73%, should be considered in relation to how managers want to use the data. For example, the model would be a great way to select images of vessel presence to send to more advanced models, like using machine learning to classify vessel types. We also plan to explore estimating vessel size using pixel size. But the full record of images may be more useful for enforcement when managers are looking to document events like illegal fishing. One example of this application is from Southern California, where M2 data were used to support the prosecution of illegal fishing within an MPA. M2 collected over 50 images of the vessel throughout its 2.5-hour trip in the area, which helped construct an understanding of the event before and after enforcement intervened on site. Thank you for taking the time to view this presentation. Visit our website for much more information on M2, or you can reach out to our team directly by email. Thank you.